Hi everyone, Major Frenchy. Welcome to another virtual pinball video. Today's video is going to be part 1 of 3, and I'm going to focus on the theory on how to connect hardware for your virtual pinball cabinet. I'm going to mostly use Arnoz solution, so they're all the different boards for the virtual pinball. Just a caveat, I have not been sponsored by Arno. I paid for all my stuff, although it was very nice to send me parts free of charge when I broke or damaged something, which happens in virtual pinball. And I just want to thank you very much, Arno, for sending these parts. Today is going to be connecting everything. So the presentation you're going to see is going to be available. The link is in the description below. Feel free to download and share. The next video is going to be I'm going to bring you in the workshop, and then we're going to connect every device with the power supply and so on. So you're going to see the actual physical side of it. And the last portion, which is going to be the third video, is going to be the software. So we're going to use Pinscape, and then we are going to configure everything in the software to make it the force feedback work. Where I'm actually in the middle of building At Games virtual pinball cabinet. I'm modding it. So I've yet installed Pinup Popper. This video is going to come. I don't know where in the sequence, but I'm going to release that very shortly as well. The Rigmaster is what we're going to use in this build, and I've played with the Rigmaster. It's a solid board, it's very complete, and then I'm going to walk you through what you can expect with this board. Now, I'm going to try to make this video very comprehensive. If you're brand new to the hobby, well, first of all, welcome. It's a very exciting experience that you're going to have ahead of you, because it's actually very rewarding. Once you get everything working and you have a fully functional virtual pinball with force feedback, it is something to be proud of. The board I'm going to talk about, this one you're seeing right now, is the Rigmaster. I call it the brain of the virtual pinball cabinet because this is where everything is centralized. And it will actually get all your toys. When I speak about toys, I mean solenoids, contactors, shaker motor, fans, LEDs. Most likely will connect to the Rigmaster. Just a quick overview of the Rigmaster. It has a KL25Z built in that's already pre-programmed when you're getting the board. Also has buttons inputs, fuse holders right on the board, has PWM outputs, extension connectors, and for additional boards, and also a plunger quick connection. So this is the top of the board of the Rigmaster, and we can see 16 outputs. So you're basically connecting your toys. Each screw terminal is going to be connecting one toy. Now there's a maximum of 5 amps and 48 volts for the devices, so you can easily connect a knocker, for example, or a chime unit. The fuse holders are built in. They're not provided with this, so you need to pick the appropriate fuse for your device. You got 8, so from port 9 to 16, they're PWM outputs. PWM are power with modulation, which means it's a variation in the current, which allows you to dim basically the lights, or to have a device, for example, a shaker motor, at a lesser intensity. So this is what these ports are for. At the bottom of the board, you will see there are like buttons inputs. So this is where you connect all your start button, your flippers will be connected on these ports. They're actually the service menu. There is actually a board called the Brain. I'm going to show you that on the screen in a few seconds. It is actually connecting directly to this if you own the board, and you just run wires from the two, and then you can mount that board anywhere you want, like on your on the back of your door or under the cabinet. Or if you do not have this service menu board and you just want to have like a regular button to do it, well, you can just use these ports here and wire your own buttons. Connecting a plunger to your virtual pinball cabinet is actually quite easy. Arnoz provides a module, which is the one you see on the right of the screen, called POTAR. It will connect directly to the matching ports on the Rigmaster, so you cannot mistake that. And then If you purchase the 3D module, which I'm going to show you on the screen, it has the attachment to connect onto the potar, and then you just like have it connected to your plunger, and then you're set. It is simple to do. Now, there's a way to add expansion boards. So for example, you notice that the top of the board has 16 outputs. If you have more than that, you can add additional boards that will give you 16 additional ports every time you connect a new board, which is quite convenient. Now let's talk about powering up the Rigmaster. So the Rigmaster will operate with 12 volts power. So you will need to get a 12 volt power supply for this purpose. And what I do personally for each power supply I own, because if you have a 12 volt toy, you need a 12 volt power supply. If you have, let's say for example, contactors that works with 24 volts, well, you're going to need a 24 volt power supply. If you have lights that work with 5 volts, you're going to need a 5 volt power supply. So all of these power supply, I have one terminal block per device. So and then everything goes through those, and I will explain to you in detail how I do that. So for the 12 volt, I have the ground terminal blocks. The ground terminal blocks, folks, is going to be central for all your power. So if you have a 12 volt, a 5 volt, and a 24 volt, the negative of all these will connect to the same ground terminal block. So this is very important. So let's just start. So I'm going to have the negative of the power supply connecting to my ground terminal block. And then I'm going to have one of the port on the other side of the ground terminal block will connect to the ground port on the left side of the Rigmaster, as you can see. And also on the right side, you got 2 additional ground screws. Now, those are not necessary. Only if you have a lot of toys, you can actually run additional ground. It is just to maintain the balance, the load on the actual board. From the 12 volt positive power supply, I'm going to run to a new terminal block for the 12 volt. So this is going to generate all the outputs for the 12 volt power supply. Each screw basically is going to be an output. From the actual 12 volt power block, I'm going to run a wire that's going to go to the 12 volt positive on the Rigmaster. So this is the terminal blocks I was talking about. If you can actually find these ones with the fork connectors, I would strongly suggest, because it is very easy to use. If you don't have those forks, you will have to bridge each port with like a wire. So it is kind of a bit of a pain. Also be mindful of the amperage. Each device have different amperage. Some of them are 15 amps. Now this specific one is 25 amps. Now we're going to talk about connecting a solenoid. I would actually strongly suggest, especially if you're new to this, consult the MJR Virtual Pinball Guide. We call it the Bible. Michael J. Roberts. Thank you so much, Michael, by the way. You're a lifesaver for a lot of people. Have a read about the electricity. I would go through the different module. It is a must, and it will save you some aggravation. Now, I'm going to talk about diodes. Now, the diodes that's provided here is a 1N4007. A diode prevents current from flying back to the board. It will only allow the current to go in one direction. So the gray bar, the solid gray bar on your diode will connect to the 12 volt of your solenoid. And the other side will connect to the negative of your solenoid. And then from there you can connect to your power and to the Rigmaster. So we're going to use the 12 volt terminal block, the same 12 volt terminal block we previously used in the previous slide, and we're going to connect it to the positive of the solenoid. The negative, where it says output controller, well, we're going to connect them to port 1 to, well, technically you can connect it from port 1 to 16. If you're using flippers, if you're using these solenoids for flippers, it's important that you use port 9 to 16 to take advantage of the flipper logics, which is kind of nice. It's built in the Pinscape. We're going to get to it when we get in the Pinscape configuration, but it prevents the basically the solenoid from burning out. And you got the fuse holder where you're going to put the appropriate fuse for your device. If your device is using 500 milliamps or something, just bump it up to 1 amp fuse. Always go a little bit above your device amperage. Now here is, so this slide addresses the flippers. So that's what I just explained. So for example, you would connect to port 9 and 10, which uses PWM. And in the config software, you would set the flipper logics, and then you would save or preserve the longevity of your solenoids. A shaker motor? Well, a shaker motor is no different than a solenoid. It's exactly the same that we just described, except you're going to connect it onto a PWM output, because you really want, especially for a shaker, you really want variation of current, because you can set the intensity in the online DOF config tool, because a motor like this at full strength, it will shake the entire house. Now, if you have interference with your shaker motor when you're connecting it, Michael J. Roberts basically advised that you should add a 4.7 microhenry inductor. And this will prevent, basically, it's a filter that will absorb the extra energy and will prevent the interference. So connecting toys, like I've just explained, are almost the same process. Actually, it is the same process for solenoids, knockers, shaker, fan, gear motor, beacon, and chime. So a lot of people do not know what these are, so I'm just going to quickly address what these are. Solenoids are designed to make noise. In a real pinball machine, they're serving a purpose. They're actually triggering mechanical features. On a virtual pinball, there's no such thing, so it only uses this noise to replicate what the real pinball is doing. So a lot of tables, they're already pre-configured with DOF, which is the direct output feedback, which we're going to get into when we are talking about the software part. But the tables are already pre-configured. Like, people have spent a lot of time to code these tables with the different effects. So what happens is, all you need to do is you need to tell the software that you have X number of device and you have them at certain position, and once you have that, the table will know and then will trigger the appropriate toy. So the solenoid, it's a clicking device, and they're strategically located in the cabinet. The knocker is a replay knocker, it's called, and it is to typically when you actually get a free game at the end of the game, the knocker will trigger. It is very loud, and it's a cool device to have. The shaker motor is basically, it's a motor with weights on each end, and it spins the axle, and then when you have a table that's coated, it will take advantage of that. It spins and it shakes the entire cabinet. For example, in Jurassic Park, when the dinosaur grabs the ball or there's a stampede, it will trigger the shaker motor, and it is a very immersive, and you're going to see a little more realistic. The fan is 12-volt fans or 24-volt fan. There are all sorts of fans. The one you connect it exactly like the other devices, except when you give it the function of fan. Well, when you have a table that's coded, for example, Whirlwind, it will blow air in your face, which is quite nice. The gear motor, I'm using an electric window motor. Some people are using wiper motors, and it is actually just to create that noise when there's something spinning on an axe, or there's I know certain tables, like you've got like guns moving on a pivot. It triggers the noise, and this is what you're going to hear. The beacon, they're the spinning red and blue lights. You've seen a lot of cabs with it. It adds a lot to the experience. I'm not going to use this in this build because of space and so on, but it is actually a nice feature to have. The chime is the bell. A lot of the EM electromechanical pinball machines are using this, and it is very loud, and it adds quite a bit to the experience as well. Now, each of the toys that I talked about, if it has a motor, if it has a coil, you put a diode in it. and you connect the positive of that toy exactly like I've shown. Now, considering that it's a 12 volt, if it's a 24 volt, you use a 24 volt power supply. And you connect them to output 1 to 16, like we've explained, and 9 to 16 are PWM. In this case, I probably would just connect the flippers and the shaker motor to these ports. Now we're going to talk about the 5 flasher bar. 5 flasher bar, they're actually fun. They actually add a lot to the experience. I think, in my own opinion, it's a must. This specific model I really like. It's Arnoz RGB lights, and the resistors are already built in, so you do not need anything else. You just plug the 12 volt and then your RGB wire, and you're set. B is for the blue, G is for the green, R is for the red, and then the 12 volts is for the obviously the power going to the light. I would definitely purchase this roll of wire. It will save your life. It has all the 4 wires together, so you can run that and it keeps like your cabinet fairly clean. These flash bars, LEDs, are gonna need PWM. Because like I've explained, PWM allows you to dim. So if you do not dim these lights, they're only going to be on or off. You're not going to see the intensity. So we definitely want that. But if you do the calculation, these lights are actually using 1 port per color. So we got 5 lights. We got 3 colors per light. That's 15 ports right there. So you would probably not have enough of the ports on the Rigmaster. So in that case, we will need an expansion board, which we're going to touch on. So we're going to need a Mollusk. The Mollusk is the extension board that adds 16 additional PWM ports to your Rigmaster. It is actually 12 volt power and ground. We're going to use the existing power blocks that we have for the previous toys that we've connected, right? So we already have that. And then we're going to connect the ground pin on the Mollusk from the ground terminal block. And the 12 volt is going to the 12 volt pin. When you're powering up the device, you should see a blue light, which means that the device is powered properly. There's one additional step that you will need to make the Mollusk speak to the Rigmaster. Is you can see at the bottom of the Mollusk, there are 7 screws, terminals. So this will connect to the matching 7 screws on the Rigmaster. They are named exactly the same. So run your wire and connect them to the Rigmaster and the Mollusk. And then you're going to pick the data in. You can see data in on the left. There's a circle. This is where you're going to... The data out on the right side is if you want to add an additional Mollusk. So the Mos'light, we're going to power the 12 volt and the ground, exactly like we did any other boards. And you're going to run matching wires from the Mollusk to the Mos'light, and then you can see the ports are matching. So 1, 1, 2, 2, 3. You just run a wire, and that way it's going to communicate with the Mollusk. And once you've got that complete, now we are ready to connect the lights. We're going to connect the 12 volt power to the pin labeled 12 volt plus on the Mos'light. And then we're going to connect the RGB, 1 color per port, per light, like so. And we're going to do the exact same thing for any additional lights that we have. And our lights are now connected. For the strobes, well, the strobes, you have typically what I do is I connect the 2 negatives of the strobe together. And I connect the 2 positive of the strobe together. You're going to run it to the 12 volt plus pin on the Mos'light on the right, and the negative will go to the port right next to it. Now, if you're running out of ports, like I've explained, the Mollusk are the extension boards. So the way you do it is you simply connect the first Mollusk to the Rigmaster, and then you have the separate port on the right, which is the data out, will go to the additional Mollusk, and so on. Now I'm going to talk about the addressable LEDs. For this, I'm using the Arnoz Pinmos, and it is quite easy to use and to set up. We will talk more about the software setup in the additional video, but for this one, I'm going to show you the connections. So the Pinmos actually is quite small. The Pinmos has 8 outputs, and we have D5, D6, D7, D8, D1, D4, D2, and D3. This is actually where you're going to connect the data signal, which is the green wire typically found on addressable LEDs strip. You can see maybe some marking that says DI if you only have the strip. If you have the one with the harness, typically it is the green wire that you would connect to one of these ports. Now there's also some dip switch that will activate a 220 ohms resistor. Some LEDs, depending on the brand you may have, may require this. For me, it worked without touching anything. The test button on the board is actually a nice touch. It will allow you to basically send a quick signal to your LEDs and you know that they are correctly connected. So let's just connect the addressable LEDs. Just so you know, my take on this is I keep everything separated from the rest of the toys. My addressable LEDs are separated power-wise and ground-wise. I keep it its own sub-environment. Addressable LEDs generate a lot of energy, and if you have something like a shaker motor triggered at the same time, it might actually conflict and damage some of the components. So I keep everything separated and never had issues that way. Take the 5 volt of the power supply, and we're going to send it to the 5 volt pin on the addressable LEDs, or your red wire if you have one. And the ground is most likely going to be black. I've seen some of them are actually white. You're going to take that and you're going to send it to the ground terminal block, which is basically the ground of the 5 volt power supply. Okay, and then the DI is the signal, and you're going to send it to on the left port of the Pinmos. In this case, it's the D5 pin. Also, you see at the bottom there's a ground just below port D3, and you're going to send that to the terminal block. Now, connecting your buttons is fairly simple. You have the button inputs on the Rigmaster, and typically you're going to find a button. You're going to have a straight pin, which is the data signal, and then the one that's at the bottom with like an L shape, this one is the ground connector. So again, for this, what I'm doing, I'm using my own terminal block. Okay, so you do not connect that to the rest of your cab. So you see on the board there are 3 connectors that are labeled ground KL. Okay, you can use these ports for your button to ground them if you wish. You only need to connect one of them. So for the terminal block, I'm just using this pin to connect, and then all buttons, the ground of the buttons, will connect on the terminal block. I just find it easier personally to connect stuff when it's on a bigger terminal block. So I'm going to run a wire from the ground, which is the bottom pin that you see, to the ground terminal block. And the data signal will go to the appropriate key that you want for your button. For example, if it's a MagnaSave or if it's a start. If you want to have backlit buttons, it's a little bit different. Well, you can run just regular power to your button and then it'll be lit. I'm skipping ahead a little bit, but if you want to take advantage of DOF and have, let's say, your start button flash when it's ready to start the game, well, you're going to need to wire it a bit differently. To make that real easy, the power that you connect the buttons, the ground of that power will go to one of the PWM port. And that way you can configure it in DOF online tool and tell that port is for the start, and the table will know that it will turn on and off that button. So that's kind of how it works. You have the positive that connects on the side pin. If you do not know which side is the positive or negative, I always just connect my button with the power and ground, and if it doesn't work, reverse the polarity, and if it works, then use a Sharpie and just put like a little mark on the pin for the ground so you know which one is which. And you're going to get the signal. The signal will going to go to, the pin on the button will go to the input button for start on the Rigmaster. And the pin that's opposite of the power you will send it to the PWM output of your choice. That's it, folks. It's very overwhelming. I know. And just take it a step at a time. Rewatch the video and download the guide. It will help you. Also, Arnoz, go through his website, and the link will be in the description below. He's got very comprehensive guides as well. Hopefully it was helpful. The next video, folks, we're going to talk about the connections. I'm going to bring you in the workshop and we're going to connect all that stuff, and it'll probably make more sense when you actually see it being done. So if you got any questions, come and see us on the Discord Virtual Pinball Chat. That's where we hang out. That's where we answer questions about virtual pinball. Lots of rooms, lots of people. We're over 7,000 people. Someone will have the answer for you for sure. And it's a friendly place, most importantly. Thank you for being with me. We will catch you in the next video.